Hello students, in the last lecture some properties of colloidal solutions we have studied, and that properties of colloidal solutions are optical properties. So in optical property we have studied Tyndall effect, how the colloidal solutions scatter the light, scattering of light by colloidal solution, due to which the path of beam of light becomes visible and it is observed by the Tyndall, therefore it is known as the Tyndall effect. We have studied also another one property of colloidal solution, that is the color of colloidal solution. Colloidal solution shows the color, and color of colloidal solution due to the light transmitted by the colloidal solutions. Colloidal solutions absorb the light of certain wavelength, and light of remaining wavelength is transmitted by colloidal solution, and therefore they show the colors. So that points we have studied. Today we have to study remaining some properties of colloidal solution. Kinetic properties of colloidal solution, in which we have to study Brownian moment, as it is discovered by Robert Brown, botanist Robert Brown discovered this moment. Also we have to study electrical properties of colloidal solution. In electrical properties of colloidal solution we have to study why the colloidal particles acquire the charge, that is charge on colloidal particle. Some other electrical properties of colloidal solutions like the electro-osmosis, and that experiment we have to study. And also we have to study electrophoresis and electro-osmosis. So see, first of all, kinetic property of colloidal solutions. The particles of colloidal solution, that is, they are in continuous and what, that is the zigzag and in random motion. This motion of the particle in zigzag manner in random direction, so that is called as the Brownian motion. It is known as the Brownian motion, Brownian movement also, Brownian motion or Brownian movement, because this movement of particles is observed under the microscope, and it is observed that particles present in colloidal solution, that is the particles of dispersed phase, are in continuous motion in zigzag manner and random direction. So you see, these are nothing but the particles of colloidal solution, that is the dispersed phase, and these particles of dispersed phase are in continuous motion and in random direction. So that zigzag motion of particles in random direction in colloidal solution is called as the Brownian motion, Brownian movement or Brownian motion, as it is discovered by the botanist Robert Brown. So it is named as the Brownian motion. Okay. Why the particles in colloidal solution of dispersed phase are in continuous motion? What is the cause? That is, there is continuous, what, that is the bombarding, continuous bombarding of fast moving molecules of dispersion medium on the dispersed phase particle, on the dispersed phase particle, so that is nothing but the continuous hammering, continuous bombardment of the dispersion medium molecule on the dispersed phase, therefore they are in continuous motion. They are in continuous motion. Second one, cause why the particles are in motion, due to the dispersed phase particle acquired. Due to this, what happened? Dispersed phase particles acquires kinetic energy from it, and therefore they are in continuous zigzag motion in random direction. So that continuous zigzag motion in random direction of this colloidal phase particles is known as the Brownian moment, or that is nothing but the kinetic property of the colloidal solution. One more reason here you have to remember, that is all the particles of dispersed phase in colloidal solutions have like charges, and therefore they does not come together. They never unite. ते कधी एकत्र येणार नाही. So when one particle goes to another particle, there will be repulsion between them, and they goes away from each other, and therefore they are in continuous zigzag motion in random direction. That continuous zigzag motion in random direction of colloidal particles present in that colloidal solution is called as the Brownian moment. So due to this, the kinetic energy is acquired by that colloidal particle, and they are in continuous motion. So that is nothing but the kinetic property of the colloidal solution. And due to this Brownian moment, the colloidal salts or colloidal solutions acquire the stability. They acquire what? That is the stability. They acquire the stability. Why? Because all particles in colloidal solutions kept away from each other. Due to this Brownian moment, they are away from each other, and hence they cannot be coagulated easily. Next one property of colloidal solution that we have to study, electrical properties. Electrical properties of colloidal solution. First of all, we have to study electrical charge on colloidal particle. Why the colloidal particle acquires charge? How the colloidal particle acquires charge? One point here you have to remember, all particles in a colloidal solution have like charges, and the charge on colloidal particle is due to preferential absorption of ions on their surface from the electrolyte. Therefore they acquire the charge. When colloidal solutions are prepared, during the preparation of colloidal solution, an electrolyte is added. What happens? From that electrolyte, preferential absorption of ions take place on the surface of colloidal particle, and due to that preferential absorption of ion, either cation or anion, they get the charge, they acquire the charge, and therefore colloidal particles acquire the charge. यानी कि जब हम colloidal dispersion प्रिपेयर करते हैं, colloidal solution प्रिपेयर करते समय उसमें इलेक्ट्रोलाइट ऐड करते हैं. इलेक्ट्रोलाइट व्हेन वी ऐड इन इट, तो इलेक्ट्रोलाइट में से आइदर केटायन और एनायन वो कोलाइडल पार्टिकल के ऊपर एड्सॉर्ब होता है, और जो भी आयन एड्सॉर्ब हुए हैं that is the charge acquired by colloidal particle. All particles absorb the same type of charge, therefore all colloidal particles in a solution have like charges, means same type of charges, and due to this colloidal particle acquires the electric charge. Okay. Secondly, here some examples are given there. That is, the which solutions, colloidal particles or colloidal solution have which type of charge. Obviously, two type of colloidal electrically charged colloidal particles will be there. Either positively charged colloidal particles or negatively charged colloidal particles. Now you see positively charged colloidal particle, hydrated metallic oxide. Hydrated metallic oxide यानी क्या metallic oxide containing required number of water molecules in it. For example, Al2O3 containing 2 moles of water or X moles of water, CrO3 containing X moles of water, ferric oxide containing X moles of water. When colloidal solutions of such oxides are prepared, then their particles are positively charged. Then the basic distuff have positively charged colloidal particle, as well as titanium oxide, metal oxide like the titanium oxide. Blood, hemoglobin, blood is a colloidal solution. Hemoglobin have positively charged colloidal particles. So that is nothing but the positively charged colloidal particle. Then see negatively charged colloidal particle. When these solutions are prepared, then at that time particles present in that colloidal solutions absorb the negatively charged particles, negatively charged ions on their surface, and they form the negatively charged colloidal particle. So here metal salts like the copper, silver, gold, then metallic sulfides like the arsenic sulfide, antimony sulfide, cadmium sulfide, they all absorb the negative charge on their surface, and there is formation of the negatively charged colloidal solution. As well as the starch solution, gum solution contains the negatively charged colloidal particle, and the gelatin as well as clay, they are colloidal solution having the negatively charged colloidal particle. So this is nothing but first one colloidal electrical property of colloidal solution, that is charge on colloidal particle. So charge on colloidal particle is due to preferential absorption of one of the ion on their surface, either cation or anion, from the electrolyte which is added during the preparation, and these are all colloidal solutions having positively charged colloidal particle, and these are the solutions having the negatively charged colloidal particle. That is nothing but the charge on colloidal particle. Now see the next one property, it is nothing but electrophoresis. So what is electrophoresis? And this experiment also we have to study. Here see, for electrophoresis we have to take this U-shaped glass tube. What we have to take, that is the U-shaped glass tube. In this U-shaped glass tube colloidal solution is taken. Then this is the electrode, that is positively charged electrode connected to positive pole of battery, that is anode, and negatively charged electrode connected to negative pole of battery, it is cathode, right? This is cathode and anode are inserted in it, and that two ends of the U-tube are plugged or fitted with the rubber cord. Now here this is the arrangement by which, this is the reservoir of solution by which we can add the solution in this U-shaped glass tube. Okay. Now when we pass electric current through this colloidal solution, we know and we have studied here, all the particles in a colloidal solutions have like charges, same type of the charges, right? So what happens if they are charged, electrically charged particle, then under the influence of influence of an electric current, under the influence of an electric current, colloidal particles migrate towards oppositely charged electrode, and they get discharged there and deposited. The process is called as electrophoresis. Unidirectional, that point also you have to remember. Unidirectional movement of colloidal particle under the influence of an electric current. They migrate towards the oppositely charged electrode, they discharge and get collected or deposited at that electrode. That process is known as electrophoresis. You see, in this experiment, in this U-shaped glass tube, we have taken one colloidal solution, electric current is applied. इलेक्ट्रिक करंट अप्लाई करने के बाद, शुरू करने के बाद, जो भी चार्ज वो कोलाइडल पार्टिकल पे है वो अपोजिटली चार्ज इलेक्ट्रोड के तरफ माइग्रेट होंगे, ट्रांसफर होंगे. यू सी, सपोज यू कंसीडर इन दिस वे, द कोलाइडल सॉल्यूशन कंटेनिंग पॉजिटिवली चार्ज कोलाइडल पार्टिकल हमने इसमें लिया है. अभी हमें मालूम है कि पॉजिटिवली चार्ज कोलाइडल पार्टिकल, सपोज ब्लड सॉल्यूशन लिया है, नहीं तो कोई भी एक ऑक्साइड और बेसिक डाइस्टर हमने इसमें लिया है. तो all colloidal particles in this way will migrate towards what, that is the oppositely charged electrode, and what happens, they get discharged here, and you will observe that colloidal particles are deposited here, which is called as its aggregation or कोएगुलेशन. कोएगुलेशन. इसमें सॉल्यूशन में जो भी कोलाइडल पार्टिकल्स हैं, हमने कंसीडर किया कि उसके ऊपर सपोज पॉजिटिव चार्ज है, एंड दैट ऑल पॉजिटिवली चार्ज कोलाइडल पार्टिकल माइग्रेट टुवर्ड्स द अपोजिटली चार्ज इलेक्ट्रोड अंडर द इंफ्लुएंस ऑफ एन इलेक्ट्रिक करंट, एंड दे गेट डिस्चार्ज एंड कोएगुलेटेड or aggregated at that electrode. So that process is called as electrophoresis. So it is known as the electrophoresis. In this way, all the colloidal particle will be discharged and get coagulated at that respective electrode. So this process is known as electrophoresis. It is known as the electrophoresis. So once again you remember, unidirectional migration or movement of colloidal particle under the influence of an electric current towards oppositely charged electrode, and they discharge and aggregate there. That process is called as electrophoresis. That is known as the electrophoresis. Now see, some another points of the applications of electrophoresis here we have to study. Significance of applications of electrophoresis. So here first one, that is to decide, to find the charge on colloidal particle. This process is useful. colloidal particle पे, उस सॉल्यूशन में जो भी कोलाइडल पार्टिकल्स हैं उसके ऊपर कौन सा चार्ज है ये डिसाइड करने के लिए इस प्रोसेस का यूज होता है. दैट इज इफ पार्टिकल्स माइग्रेट टुवर्ड्स नेगेटिवली चार्ज इलेक्ट्रोड, दे हैव पॉजिटिव चार्ज, एंड इफ पार्टिकल माइग्रेट टुवर्ड्स पॉजिटिवली चार्ज इलेक्ट्रोड, दे हैव नेगेटिव चार्ज. देयरफॉर टू डिसाइड, टू डिटरमाइन और टू फाइंड आउट what is the charge on colloidal particle, that is decided by the process of electrolysis, as well as to separate the colloidal solutions of different charge particles, it is useful. And third one, for coagulation of the colloidal solutions, the process is useful. अगर दो कोलाइडल सॉल्यूशन जिसमें चार्ज डिफरेंट है, यानी कि एक के ऊपर पॉजिटिव एक के ऊपर नेगेटिव और उसका मिक्सचर है, तो वी कैन सेपरेट बिकॉज पॉजिटिवली चार्ज कोलाइडल पार्टिकल माइग्रेट टुवर्ड्स नेगेटिवली चार्ज इलेक्ट्रोड and negatively charged colloidal particles will migrate towards the positively charged electron, so they will be separated, particles will be separated. And one more point, that is one more application for coagulation of colloidal solution, it is useful. Coagulation यानी क्या? From colloidal solutions, aggregation of all colloidal particles by removing the charge of colloidal particle, that is called as the coagulation. And in coagulation process there is use of the electrophoresis process. So this is about the electrophoresis. Now one more electrical property of the colloidal solutions here we have to study that electrical property of colloidal solution is electroosmosis. So that we have to study. Can see the next one, colloidal property, it is electroosmosis. Third one, electroosmosis. See, electroosmosis is the process in which that is the electroosmosis. Okay. Now you see the electrophoresis we know. In this electrophoresis, if we place that is the semi-permeable membrane at the middle of this tube. Listen and understand. अगर हमने इस U ट्यूब में semi-permeable membrane fix किया, and process is same now. See, under the influence of an electric current, unidirectional of dispersion medium now. इस प्रोसेस में क्या होता था? Dispersed phase particles are migrated towards the oppositely charged electron. मगर इस प्रोसेस में क्या होता है? Dispersion medium particle, solvent particle migrate. So see, that is unidirectional migration or moment of dispersion medium that is nothing but the solvent molecules through semi-permeable membrane under the influence of an electric current, that molecules get migrated or migrates to or into opposite direction of the colloidal particles, that process is known as electroosmosis. You see, here in electrophoresis, suppose particles have positive charge, they migrate towards the negatively charged electron. अभी हमने इसमें क्या किया है कि सेमी परमेबल मेम्ब्रेन वो ट्यूब में फिक्स किया, and the process applied is same, that is electric current is passed. When the electric current is passed, then unidirectional flow movement of dispersion medium. अभी क्या होगा मालूम है, इसमें से dispersion medium के particles molecule इधर आएंगे और here level of solvent will be increases in this tube and level of solvent will be decreases in this arm. इस आर्म में सॉल्वेंट की लेवल डिक्रीज होगी, इस आर्म में सॉल्वेंट की लेवल इंक्रीज होगी, बिकॉज यूनिडायरेक्शनल माइग्रेशन ऑफ द डिस्पर्शन मीडियम मॉलिक्यूल, solvent molecule through semi-permeable membrane in the opposite direction to that of the colloidal particle under the influence of an electric current, that is called as electroosmosis. उसे electroosmosis कहते हैं और this process is called as electrophoresis. So don't forget, while electroosmosis only we have to place a semi-permeable membrane and apply the electric current. Through that semi-permeable membrane, solvent molecule migrate towards the oppositely charged electron to that of the colloidal particle migrating which direction? त्यांच्या opposite direction ला solvent और medium चे particle migrate होतात, and that process is called as the electroosmosis process. This is known as what? That is the electroosmosis process, and these are nothing but the electrical properties of the colloidal solutions. One more point which is remaining from this chapter, that is about colloidal solution. It is coagulation of colloidal solution, and we have to study few points about the emulsion, and lastly we will study applications of colloidal solution. That we will study in the next lecture.